Hi everyone and welcome back to PrepFusion. I am Anish and today we will start with the lecture 2 of our network theorems for AC circuits. So today we will solve the assignment questions which I gave you as homework and few more new questions as well. So let's go to the first homework questions. So I think we did a lot of things. So yeah, this was I think was the first no this was the first homework question, I believe. Yes, this was the first homework question. Rather simple question. So you have been given this voltage, okay, and we have to find the amplitude of v of t if input is doubled along with the phase lead of 150 degrees. So simply it will just follow the linearity property. So we first I will directly write the answer. If input is double, right, then the output also will be doubled. Okay, so if input has been changed, if v in has been changed from 2 sine, okay, just hold on, 2 sine 2t minus 60 to this will be double, right? So this will be 4 sine 2t minus 60 plus 150. I have provided a phase lead of 150. So if I add plus 150, this will be plus 90. Okay. So basically, how the response will change. So for this, right, what was the response? The response was 5.338. 5.38. Okay, actually, right, I should have mentioned that this is the the peak value. It should have been mentioned. I'm sorry, I should have mentioned this is the peak value. I did not mention it. That's fine, whatever is the response. So it is 5.38, right? Angle minus 128.2 degrees. So this will be simply changed. This will also be doubled, right? So if I double this will be 10.76 angle. Now I have to add a phase lead of 150. So because I have added a phase lead of 150 and it is a simple linear circuit, so of course it will follow the property of linearity, right? Because it only contains elements L, R and C. So this will be added 150, so this will be plus angle 21.8 degrees. Okay, so this will be the answer. So let us cross verify. So let me first cross verify for the first, this one, right, whether it is correct or not. So I will apply a KCL here. Okay, so basically it will be V. So let me write this in phasor. 2 angle minus 60. What will be the impedance here? This will be plus J2. This will be 1 by J2. This will be V divide V minus 2 angle minus 60 divide by 1. Okay, then I have here I have something like this, right? This is V. Okay, this is V minus 0 divided by J2 plus V minus 0 divided by 1 by J2 equals to 0. So this will be V into 1 plus 1 by J2 plus J2, and on the right hand side it will be 2 angle 60. So ultimately my V, right, this will be minus J minus 0.5. This, so this will be 2 angle 60 divided by 1 plus J 1.5. Okay, so yeah, this is the case. So now this will be, yeah, actually I made a mistake here, this, right, this is wrong actually. my bad. So I have to change in the question. So I will just calculate this value. I'm really sorry. I have to calculate this value, right? I will just calculate. This value will be so 1 plus 1.5 whole square, 1 plus 1.5 whole square, whole under root inverse into 2. So this will be 1.11 angle. What will be the angle? Angle will be 1.5 divided by 1 tan inverse and plus 60. It will be 3.69. So I'm really sorry. Basically, right, this is my bad. This will be 1.11 3.69. This will be 1.11 3.69 degrees. Okay, so this, right, I have to change actually in the assignment question PDF as well. I will just quickly change this here. I am sorry, that's what happens when you don't calculate properly. So basically this will be 1.11. So basically, right, what will change basically, so this value will be 1.11 angle 6.39. So if I have multiplied by 2, right, the input source, this also will be multiplied by 2, and the phase also will be added with 150. So this will be 153.69. So let's check whether it is true or not. Okay, so like my input, right, V is here, right, V is here. So this equation is same because frequency is same. This equation will not change, right? Only the input V is changed, and V is only present here. This input is present only here. Everywhere else it is not present. So ultimately the final equation that I will get is V into 1 plus J 2 minus 0.5, and on the right hand side it will be the new phase, that is 4 sine into 2t plus 90, that is 4 angle plus 90. Okay. Okay, one again, another mistake I have made. This is minus 60, right? If this is minus 60, that means this, right, will be actually minus 63. I'm sorry. So this is 1.5 tan inverse minus 60. This will be minus 116.3. I'm sorry, minus 116.31 degrees. Okay, fine. Yeah, now I guess it is fine. Yeah. So your V, right, here it will be minus 100 and, okay, I'm making so many mistakes, I'm really sorry, minus 116.31 degrees. This also will be minus 116.31 degrees. Okay, so now, yeah, that is the case basically. So again, if ultimately this value will have been shifted, so you will solve this equation and you will get back the result as this will be 2.22. Okay, and an extra 150 will be added with the angle. So if I add 150 with the angle, this will be 33.69. So this will be your answer of the question. Okay, I'm sorry for the mess ups. So your answer will be, this will be minus 116.31, and this will be plus 33.69 degrees. Okay, so yeah, that is the answer of this particular question. So yeah, I hope you have learned something. So you should always back calculate and check your calculations, right? So I was bit off there, so I'm sorry. Now let's move on to this next question. So this question is also pretty simple. You just have to use the superposition theorem, right? So first I will calculate for this voltage source, make this current source like 0, make the effect of this current source to be 0. So how do you remove the current source? You make it open circuit. So because I have to make the I equal to 0, I equal to 0 means open circuit. So my circuit will be converted to, first I will choose the voltage source. Circuit will be somewhat like this. Zero 0.2, this will be 8 ohms, and this is plus minus V0. This is just a dependent voltage. Oh no, this is just V0. V0 we have to calculate, right? This will be Now what is 0.2 farad? Basically this will be 1 by j only, 1 by j. This will be 5 j5, and this will be 75 sine 5t. Okay, so this value I need to find out v naught, right? So I can apply a KCL here. So this will be v naught minus, I can change this to phasor. So this will be 75 angle 0, assuming sine 5t to be my reference. So 75 angle 0 I will assume. So this will be v naught minus 75 angle 0 divided by 8 ohms, then plus v naught by 1 by j minus 0 actually, because this point is grounded basically, plus v naught minus 0 divided by j5. So your like this is equals to 0, right? The KCL. So this will be v naught. So this is v naught dash basically. So I'm not exactly calculating v naught. I'm calculating v naught dash basically. This is the effect of the only the 75 volt source. Okay. So from here, what will be my v naught dash? V naught dash. This will be j like 1 by 8 plus j 1 minus 0.2. Okay, and this will be basically 75 angle 0 divided by 8. V naught dash. So this will be right. If I multiply on 8 both sides, this will be 75 angle 0 divided by 1. This will be 0.8 into 8. 0.8 into 8 will be 6.4. Okay, so now if I solve this, what this will come out to be? So 6.4 whole square plus 1 under root into 75. Okay, so it gone, it went off. So plus 1 whole under root into 75, 11.578. Okay, this is the voltage value basically. And what is the phasor angle? Angle I have to calculate. This will be 6.4 divided by 1 tan inverse. So it is minus 81.2 degrees. Okay, so this is the basically voltage. So I can write v naught dash as 11.578 sine of 5t, because that this was my initial phasor, minus 81.12 degrees. Okay, so this is the first, the voltage due to the only the 5 volt voltage source. Okay, let me just bring this a bit down. Yeah, voltage due to the 5 volt voltage source. Just hold on, now it is fine. Okay, now let us calculate the voltage due to the current source. So if I have to deactivate this voltage source, how do I deactivate? I make it 0. How do you make a voltage source 0? You do short circuit, because the voltage across it is 0. Okay, so you will short circuit this voltage source. This will be the resistor. This will be the 1 by j impedance. Okay, and this will be the this will be the like L, right? L is here, so this is the J here, and R is here. R is 8 ohms, and the current source is here, right? Current source is here. So I will assume cos. Now I will assume cos to be my reference, and of course, okay, what is its frequency? Okay, its frequency is different, right? Sorry. Its frequency is different. So this right, this will be what? JC, omega c is 2. So this will be 1 by 2j. I'm sorry, this will be 1 by j2, and this will be 10 times omega L. So this will be basically j10, correct? And this is my current source. Now of course the frequency is different, so as assumption is my cos 10t is the reference now. Okay, assumption is reference is cos 10t. I can choose whatever I want. Okay, this is equivalent to 1 angle 0, and here my reference was sine 5t, which is 1 angle 0. Okay, so this, now I can, we have to calculate the VO, right? Again I will apply the KCL. So this will be VO minus 0 by 8, because this is grounded. So VO minus 0 by 8 plus VO minus 0 by 1 by J2 plus VO by J10 minus the current is incoming 6 angle 0 minus 0 by J10 equals to 0. So this will be rather simple. This is just like a parallel circuit, right? So my VO, this is VO double dash. I'm sorry, this is VO double dash. Previously it was VO dash. This is VO dash. Okay, because why double dash? Because I'm calculating with respect to the current source. Ultimately I will add the two up, because I can use the superposition principle. So VO double dash, if I multiply, like what is this? This is basically 1 by 8 plus J 2 minus 0.1 equals to 6 angle 0. Okay, so VO double dash, if I multiply by 8 on both sides, okay, this will be 8 into 6, that is 48 angle 0 divided by 1 plus J 1.9. Okay, so so this is 1 square plus 1.9, so 1.9 whole square plus 1 whole under root. So this is VO double dash equals to 2.14, right? It is 2.14 into 48, so this will be 22.356, and it is 1.9 divided by 1 tan inverse, so it will be 62.24 degrees. Okay, so this is the voltage due to the current source. Okay, so you can of course write down this with respect to the, am I doing everything correctly here? I think mostly it should be correct. Okay, voltage, it will be some division. Yeah, we can do the current division as well, we can do anything. So I'm just calculating, is everything correct here? Just seeing is everything correct here? 6 angle 0 is, everything is correct. Okay, this 8 is getting multiplied there. Okay, I made a mistake. This, right, 8 will get multiplied here, right? I'm sorry, 1.9 into 8, because I have multiplied 8 on both sides. Basically I have taken the 8, right? So yeah, I was making some mistake. That is what I was thinking, because answer was not matching. So this is 1.9 into 8 whole square plus 1, then under root. So this will be 15.23 into 48. So this will come out to be 3.151. Okay, and what about the angle? Angle will be, I think, almost very close to minus 90 or something. Okay, so this will be 1.9 into 8 divided by 1 tan inverse, say minus 86.236. Okay, so yeah, this is the voltage basically, and this is the angle. Okay, I hope you understood. So if I go back to my actual form of sinusoids, this will be 3.151 cos of 10t minus 86.236. So what is my actual voltage? So that's why AC questions are generally lengthy, and that's why generally they don't ask questions from AC, because they also know like the calculations will be super lengthy, right? So your VO will be the sum of VO dash plus VO double dash. So it will be equals to, the first one we calculated 11.578 sine of 5t, what was the angle, minus 81.12 degrees, then plus VO double dash 3.151 cos of 10t minus 86.236 degrees. Okay, so yeah, this is the final answer of this question basically. So that's why AC questions are generally lengthy, and these questions will not come. That's why I left it as homework, because the brainstorming questions I took in the previous lecture basically. So these were basically the lengthy parts only. So I think this one, yeah, this one we already solved. Now let's come to the actual assignment questions. We are yet to come to the assignment questions. Oh, okay, this was also another homework, I believe. Yeah, this was also another homework, I think. Yes, this was also another homework. That's 62 one, right? So this is the homework. So you have to find out the Thevenin's equivalent circuit of this question. So I don't think like it would have been much difficult. So first of all, let's calculate the ZTH or VTH, anything was. Let's calculate the VTH first. So if I want to calculate the VTH, I have to calculate the open circuit voltage. So current through here will be 0. Current through here will be 0. So basically, right, here through here also current is 0. So no drop across this resistor. So ultimately, right, current through here is 0. So ultimately all of these are in series. So I can just use the voltage divider rule and calculate the voltage across this. So that will give me VA, and here, right, this is just ground, right, because if I assume this to be ground, this will be also ground. Why? Because no current is flowing, there is no drop across the resistor. So my VA, my VOC will be equals to VTH will be equals to the simple voltage division. So 75 angle 20 into minus J4 divided by 6 plus J2 minus J4. So this will be equals to, this will be basically equals to 6, so this is 6 square plus 2 square, okay, under root. So this is 75 angle 20, and this is 4 angle minus 90, right, 4 angle minus 90, and this is 6.324, and what is the angle? Angle is minus 2 by 6. Okay, minus 2 by 6 minus 18. So angle is minus 18 actually. (18.44 degree). So now, right, what will be this value? This minus 90. So angle is plus 20. I also have to do. So this, right, this will be, angle will be minus 51.56. Okay, and what about the this magnitude? Magnitude will be 4 divided by 6.324 into 75, so it is 47.43. 47.438. Okay, so this is the open circuit voltage. What about the impedance, Thevenin impedance? So Thevenin impedance is rather simple. Just we have to, what we have to deactivate the sources. So if I deactivate this source, this and this will be in parallel, and ultimately this will be in series. So the circuit will get reduced. This is what, 6 ohm plus J2, okay, and this is minus J4, and this is 10 ohms. Okay, so ZTH you have to find, that is not that difficult. So ZTH will be equals to uh, so first I will calculate the parallel. So this is 6 plus J2 into minus J4 divided by 6 plus J2 minus J4 plus 10 ohms. Now I will calculate the things. So right, this will be how much, 6 square. So let us convert everything into polar. It will be simply, it will be easier for us. So 2 divided by 6 tan inverse is 18 point something, I think. Yeah, this angle is 18.44. This angle is into 4 angle minus 90. And what is the magnitude of this one? 40 under root is 6.32 divided by, what is the magnitude? This is also 6.32 only, but the angle will be just opposite, 18.44. okay, and plus 10 is of course there. So 6.32 will get cancelled. This will be 36 point something. So 18.44 into 2, 36.88 angle 4 angle 36.8. okay, minus 90 is also there, right? Minus 90, so this will be minus 53.12 degrees plus 10 angle 0. This is basically a pure resistance, correct? So this will be 53.12. Cos of this is 0.6, so this will be 2.4 minus j sine of this. So it is 8 into this, so 8 into 4, 8 into 4 is 3.2 plus 10. okay, so this will be 12.4 minus j 3.2. so if I want to write this in polar, into 3.2 tan inverse, okay, this will be something 14 point minus 14.47 degrees. What about the magnitude? Magnitude will be 12.4 whole square plus 3.2 whole square under root, so it will be 12.8. okay, 12.8. So like this is the ZTH and this is the VTH. So you can equivalently replace your circuit with VTH. What is the VTH? VTH is VTH we found out was 47.438. 47.438 angle is how much? Angle is minus 51.56. And what is the ZTH? ZTH is 12.8 angle minus 14.47 degrees. So like this you can convert your circuit. Okay, this is how you use Thevenin's, and these questions will rarely be asked because I hope you understand, like there are so many calculations. So let's now move on to the next like actual assignment questions. I think finally we will be able to move to the actual assignment questions. So yeah, this is the first assignment question that we had, right? So we had to find out the maximum, like the value of PL max, find the maximum load power. Okay, so how do you find out? So you here, right, only your RL is variable, and whenever only RL is variable, what was the formula? I hope you remember, right? It is basically the magnitude of RS whole square plus the reactive part. So remember, take care of the signs, right? Make sure you write the signs properly. Make sure you write the signs properly. Here the reactants are opposite, so it will be minus 10 plus 15 whole square. Just be careful about that, right? So it is XL plus XC, load reactance plus the source reactance, and here both are of opposite sign, right? That's why you will write with a negative sign. So this will be 10 square, RS is 10 ohms, this will be minus 10 plus 15 whole square. So RL will be equals to 10 square plus 25 under root, so it is 11 11.18 ohms. Okay, just hold on. Is my laptop burning? Because I am getting a burning smell. I think it is something, it is of something else. Okay, so it is 11.18. So now this is the like RL for which the maximum power transfer will happen, but they have not asked this, right? They have asked me that what is the maximum power transferred. So I have to find out the PL max. So for that, right, I first of all need to calculate the IL. So basically this circuit will be replaced with RL equals to 11.18 ohms. Okay, so this is my input voltage V divided by 10 minus J10 plus J15 plus 11.18. Okay, so this is the, like if I want to calculate the magnitude of current, this is how we will calculate. So it will be 100, this is 100 angle 0, so 100 divided by 21.18 whole square plus 5 whole square. So this will be plus 10 whole squared plus 25, and of course then I have to take the under root as well, right? Don't forget to take the under root as well. So oh my god, let me bring it down. This will be 100 divided by 21.762. Okay, so what will be your current if I just multiply 100 with it? So it will be 4.6, so it is almost approximately equals to 4.6. okay, I don't care about the phase, I just care about the magnitude, right? This is the magnitude of current, I just care about the magnitude. So from here you can directly write that PL max, that is power delivered maximum across the load, will be max I RMS according to R. Here, right, nothing is mentioned whether this is RMS or peak, so you will assume to be peak. So this will be, so assume to be RMS, sorry, assume to be RMS. But generally, right, in standard questions it will be mentioned. Don't worry, in standard questions it will be mentioned, so you don't have to worry. So this is also RMS, so it will be 4.6 whole square into R. Okay, so 4.6 whole square into R, that is 21.11 into R. So RL is what? RL is 11.18. So into 11.18, so it is 236 watts. Okay, so this is the maximum power transferred. This will be the answer of this question, 236 watts. So that's how you calculate using this formula. So let's now solve the next one. Here, right, they have asked find the maximum load power PL max. Again the same thing, but this time, right, it is ZL. So ZL can be written as R plus JXL, right? ZL can be written as RL plus JXL. So both are varying now. So what will be the condition for maximum power transfer? ZL will be equals to ZTH conjugate. So it has to be conjugate. So for that I have to first of all find out the ZTH, and also I have to find out the VTH is not required because I can directly calculate the current. Okay, VTH is not required, we can directly calculate the current. So yeah, so let's first put this in action. So we have to find out the Thevenin's equivalent impedance. So Thevenin's equivalent impedance, this, right, will be short circuited basically. This is short circuited, so the impedance is somewhat like this. Okay, so it is basically minus J minus J50 plus 50 into J50 divided by 50 only, because basically, right, what you're doing, you're adding everything, minus J50 plus J50. So this will be basically 50 will get cancelled and J will be there, so it will be 50 plus J50. Okay, so this will be your ZTH, but my ZL will be what? ZTH conjugate, so it will be 50 minus J50. Okay, so now there are two ways to go about it. Either you draw the Thevenin's equivalent. So method one is directly solve the, like, you replace this right here, and you basically, right, you copy, I have copied the circuit. Okay, not this one. You copy this circuit, paste it here, and you replace your ZL with what? With a, what is it? It is minus J50, right? So it will be a capacitance of minus J50 and a resistance of plus 50. Actually these two are in exactly parallel. Okay, that is very, very interesting actually. Okay, so either you can apply a KCL here. At this node you can apply KCL here, and from there you can find out the current, magnitude of current, and then you just do, for PL you just do magnitude of I square R, that is magnitude of I square into 50, because R is 50 in this case. Okay, so what is the method 2? Method 2 is convert this into Thevenin equivalent. So because already I have calculated the Thevenin impedance, let's calculate the Thevenin open circuit voltage. To calculate the Thevenin open circuit voltage, I have to open circuit the voltage. I have to open circuit the load basically. So this will be the voltage basically. I can apply a nodal again here. Sorry, not nodal, or KCL, nodal or KCL, whatever you prefer. So this will be 50 V minus 50, like VTH minus 50 by J50 plus VTH minus 0, this is ground, divide by 50 minus J50 equals to 0 basically, because this is open circuit, correct? Or like, okay, I don't even need to do this. This is simply a voltage division, right? voltage division is happening. What am I doing? Okay, simple voltage division is happening. So VTH, right, will be equals to 50 angle 0, 50 angle 0 into the like the impedance across the load, into this addition, right, 50 minus J50 plus J50. So this will be so 50 has been cancelled. So this is 50 minus J50. So this will be 50 minus J50. So VTH will be 50 minus J50. So my circuit, right, can be replaced like this: 50 minus J50. This is the Thevenin's impedance, 50 plus J50, I guess, and this was the load, I think, load impedance minus J50 divided by 50. Okay, so you can further like write this. So what will be the current here? The current, right, in the circuit will be voltage, Thevenin voltage minus J50 divided by the total impedance. So impedance is basically 50 will get added, this will be 100. Okay, magnitude will be magnitude of this basically. So 50 I can take common, so this will be 1 by 2. Okay, 1 plus 2 under root 2. Okay, so this will be 1 by under root 2. Okay, I am just concerned about the magnitude, I am not concerned about the phase. So what will be the PL max? PL max will be magnitude of I square into R. So it will be 1 by under root 2 whole square into R. R is 50. So this will be 50 by 2. So this is 25 watts. So 25 watts will be the answer. Okay, 25 watts will be the answer. Okay. So yeah, this was the next question. I know it is, we are pushing a bit, but that's fine, right? So mostly we will do all the questions in this lecture only. So we have to determine the maximum power dissipated across the load in the watts. So now, right, your inductance is varying. So what will you make your inductance so that maximum power transfer happens? Negative of this, negative of the reactance of the source. So my XL for maximum power transfer, maximum power transfer, XL should be equals to minus of negative of minus of 10, minus of J10, so it will be plus J10. That is what you have to be careful, because already the J sign is there, so I will not include the J sign basically. So this will be plus J10, right? That is only thing that you need to take care, and after that everything is sorted, right? Then your, what will be your magnitude of current? Your magnitude of current will be the voltage, magnitude of the voltage. Voltage is what? 50 angle 0, 50 angle 0 divided by this whole resistance, 10 minus J10 plus J10 plus 10. So 10 minus J10 plus 10 plus J10 magnitude. So this will be 20. So this will be 5 by 2. Yeah, this will be 5 by 2 only, because the imaginary part is totally gone. So what will be the power? Have they asked the power? Yes, they have asked the maximum power dissipated across the load. So this will be PL max will be magnitude of I whole square into R. So this is 25 by 4 into R. R is resistance is 10 ohms. So this will be 10 ohms. So it is 6.25. So this is 62.5 watts. Okay, so this will be the answer of this question. So this was the last question that I gave you as the assignment. So this is a gate question basically, and where they are asking the value of C required for maximum power transfer. So they are doing very interesting thing, right? They are varying the C only. They are only varying the C, okay, and they want us to find out the value of C for which maximum power transfer will occur. So this is not a very standard question. Load is this one, okay, not a very standard question. So how do I how do I make how do I make like how do I come to the condition for maximum power transfer? What we used to do, first of all, I told you, for maximum power transfer the reactance should be 0 because the source does not have any reactance. This also should be negative of the source reactance, that is 0. So here also I should try to make the reactance to be 0 or minimum at best. So my ZL, like this is the load, right? They have specifically said that this is my load, this is my source. The source only has resistance, it does not have reactance. So my load also should not have reactance so that the current is maximum because the impedance will be minimum. So that should be my first target. So I will write for PL max, the current has to be maximum. Current has to be maximum. That is my impedance has to be minimum. Obviously R, I cannot vary the R, our real part is constant, I can vary imaginarily. So my XL has to be minimum, that is XL equals to 0. That is the load reactance. I'm not talking about the inductance, I'm talking about the load reactance. So imaginary, I have to, like this is my condition basically for maxima, imaginary of ZL must be 0. So what is ZL? ZL basically, if I write it, this is a series combination of the coil. So this will be j omega L plus the parallel combination of the resistor and the capacitor. So this will be 1, that is a resistor, into 1 by j omega c divided by 1 plus 1 by j omega c. So let me check everything is recording. Yes. So my ZL, what is omega? Omega is 100, right? Omega is 100. L is 5 millihenry. So 5 millihenry into 100 will be 0.5. This will be J 0.5. And again here omega is 100. But what is your capacitor? Capacitance is C only. Okay, it is. So if I multiply by omega C on both sides, this will be 1 divided by J 100 C plus 1. Okay, so now if I rationalize this thing, this will be ZL will be equals to J 0.5 plus J 100 C. Let's do one thing, let's not do like this, let's do like this, 1 minus J 100 C. I will tell you the reason. This will be 1 square plus 100 C square. The reason is because this one, right, I have to make it negative so that I can cancel out. So that's why I need a negative sign with the 100 C. Okay, so that was the main purpose of getting a negative sign here. So now I can contain the like terms, like the real terms, plus J 0.5 into 100 C into 1 square into 100 C whole square. Okay, so now I have to make the imaginary of ZL to be 0, then only of course maximum power transfer will happen. This we already know, right? We have to make the imaginary part 0, correct? Because the source does not have any reactance, the load also should not have any reactance, so it is purely resistive, so all of the current, like impedance, will be minimized then. So I hope you get the point. So this will be basically 0.5 minus 100 C 1 square plus 100 C whole square equals to 0. So okay, this will be 1 square plus 100 C whole square equals to 200C. So this will be C square plus 2 by 100 C plus 1 by 100 square. So now I can use the Sridhar Acharya formula. So Sridhar Acharya formula is plus minus B. So that is 1 by 50 plus minus B square, that is 1 by 50 whole square minus 4AC. So this is basically 4 by 10 raised to power 4. Okay. So ultimately, right, this is divided by 2. So is this becoming a whole square like kind of thing? Okay, sorry. One more mistake. This is negative, right? So this will be positive. Okay, because I think this one will cancel each other out. This one is cancelling each other out because this is just a perfect square. So this one will come out to be 1 by 100. Okay. So what is 1 by 100? What have they asked? In millifarads. They have asked in either millifarads or micro. So this if I multiply by 10 raised to power 3 on both sides, on numerator and denominator, 10 cube. Okay, sorry, this is 0.1, right? 0.1 farad, sorry, not 0.1, 0.01 farad or 10 millifarad. How can I write 10 millifarad? Basically this is 10 into 10 raised to power minus 3 farad, right? Same. So this will be 10 millifarad. 10 millifarad will be the answer of this question. Option D will be the answer of this question. So I hope you understand the case. Anyways, yeah, everything was simple. So I hope you understand why we are making the imaginary part to be 0, because I want the current to be maximum, I want the impedance to be minimum, then only power will be maximum. Now let's do this question. So 2 questions are left. So this is the second last question. Try it out by yourself. Pause the video and try it out by yourself. So I have a linear network consisting of resistive, inductive and capacitive elements connected to a voltage source and a current source. Okay, and if I observe both have frequency omega, their phase difference is difference alpha beta. Okay, and their obviously peak values will be different. The magnitude of the Thevenin resistance is equal to the magnitude of the Thevenin reactance. So basically what they have told me is the magnitude of the Thevenin resistance of this circuit is equals to the magnitude of the Thevenin reactance. Okay, so ultimately, right, like Thevenin resistance is positive only. So basically Thevenin resistance is equals to Thevenin reactance. That is what they are telling me. So my ZTH I can write as RTH plus JXTH. This can be written into a single variable RTH plus XTH. Okay, that is what we can do basically. So now what are they asking? The graph below represents the variation of power consumed with respect to the change in resistance. So the graph below represents the variation of power consumed with respect to change in resistance. Okay, so how much power is getting consumed in the circuit, in the load, with respect to the resistance? Actually it should have told consumed in the load. Actually power consumed in watts in load I should have mentioned. So this is my load basically. So I forgot, like I will just change in my assignment questions, else you guys will get confused. So this is my load basically. Okay, and this is in watts in load. Okay, so if the load is now replaced with a simple series RLC circuit, determine the maximum power transfer to the load. Okay, so currently the load is purely resistive because only I am varying the resistance only. So it is telling me the graph below represents the power consumed with respect to change in resistance. So with where the initial load is purely resistive. So initially my load was purely resistive and I was getting maximum power at RL equals to 25. So do you remember the condition where I was only varying my load resistance? What was the condition for maximum power transfer? The condition was that RL will be equals to under root RTH whole square plus XTH whole square. If you remember the condition, right? This was the condition basically. Okay, so this right, this is not technically correct because I don't know the behavior of my reactance. Is it capacitive or inductive? Because this is true, magnitude is true, but I don't know what is the sign of XTS. It can be positive or negative depending whether the reactance is inductive or capacitive. So, but this much I know, that I don't care if it is positive or negative, XTH whole square will be equals to RTH whole square. That much I know. So RTH whole square will be equals to XTH whole square, because if you square a negative number or a positive number, ultimately it is the positive number only. So your RL will be basically under root RTH whole square plus RTH whole square. Okay, so your RL equals to under root 2 RTH. Okay, under root 2 RTH. So uh, so my so my RL, right, because this is the condition for maximum power transfer, right? If you remember, this was the condition for maximum power transfer. Okay, so when is it happening? At 25 ohms, right? So this is equals to 25 ohms. This is equals to 25 ohms actually, because at this point the maximum power transfer is actually happening. So from here, right, I can directly find out my RTH. RTH will be 25 by root 2. Okay. Okay, sorry, this is 25 only. RTH will come out. Yeah, RTH will be equals to 25 by root 2. RTH will be equals to 25 by root 2. Okay. Now what about XTH? So XTH also will be equals to, like, magnitude of XTH, right, will be equals to 25 by root 2. But I don't know. I don't know whether uh, I don't know whether it will be like positive or negative. That much I don't know. But magnitude I can surely say that it will be 25 by root 2. Okay. And what else? I have got the VTH. It is now they are telling me if it is replaced with the series RLC circuit, determine the maximum power transfer to the load. So if it is replaced with the series RLC circuit, okay. So if it is replaced with the series RLC circuit, right? So now in the second case, case 2, my ZL is equals to RL plus J XL minus XC. Okay, so I need the maximum power transfer. So ultimately, right, this has to be 0, right? XC has to be equals to XL. Or no, not this, no. For maximum power transfer, this does not have to be equal to 0. My ZS source resistance is RTH plus JXTH. So basically, right, XL minus XC, magnitude of XL minus XC has to be equals to XTH, but phase will be opposite, sign will be opposite. Okay, so ultimately, right, this imaginary portion will get cancelled out. So basically my overall impedance will be RL plus RTH. Okay, and I know at maximum power transfer my RTH is equals to RL, correct? So ultimately, right, your overall R equivalent, overall Z equivalent, right, is only this much, right, correct? Is 2 times RTH, that is 25 under root 2. Okay, so it is 25 under root 2. R square I will get, yeah, it is fine. Okay, 25 under root 2. Now they are just asking to find the maximum power transfer. So what is the maximum power transfer? Maximum power transfer rate is PL max will be magnitude of I whole square into RL. So it will be magnitude of I will be the voltage divided by current. What is the voltage? Now voltage I don't know. Okay. Voltage I don't know. I don't know what is the voltage. But here, right, something is present. So this 2500 watts is present. So I can take the hint from this and find out the voltage as well. So previously what was the maximum power transfer? Previously the PL max in the case, this is the case 1, right? This is the case 2. case 1, case 2. Okay, so this will be basically 2000 uh, 225 this 25 so PL max is 2500. So what is it equals to actually? It is equals to I max RMS I square RMS into RL. So RL I already know, right? RL is 25 by, sorry, RL is 25 only because they have given me this value. RL is 25 only. So basically my I magnitude whole square is 100. So I magnitude is 10. Okay, it is 10 amperes. Now I magnitude is 10 amperes. What else can I say? What else can I talk about? I can talk about this thing that my what do you say, VTH. What will be VTH? Because my equivalent circuit, right? Equivalent circuit will be somewhat like this. This is my VTH. This is my RTH plus JXTH, and this is my load. Initially my load was only purely resistive, correct? Initially my load was only purely resistive. So load was 25 only 25 ohms. Yes. Load was 25 ohms only, correct? Yes, load was 25 ohms only. Okay. Okay, so now what is the open circuit voltage? That is what I wanted to find out. Like we just need the magnitude mainly, right? We need the magnitude. So I know this formula for magnitude of I comes from what? VTH magnitude divided by the impedance, correct? So it is VTH is VTH, magnitude of VTH. So basically, right, my magnitude of VTH will be magnitude of I into magnitude of Z. So I, magnitude of I is 10. What is the magnitude of Z? Magnitude of Z is RTH plus this 25 whole square plus XTH whole square whole under root. So this will be equals to what is RTH and XTH? RTH is 25 by root 2, right? So 25 by root 2 plus 25 whole square. So this is 10 times 18 to 1.38 plus 25 by root 2 whole square 312.5 whole under root. So this will be equals to 312.5 plus 18.21.38. okay 312.5 plus 18.21.38 under root into 10. So your magnitude of VTH comes out to be 400 and something, right? 462 volts. Okay, so I don't need the phase actually, I just need the magnitude. I will explain why. Okay, so now I have got the magnitude, right? So what is this I? So now, right, your circuit, your equivalent circuit is what? Your equivalent circuit now is basically, this is your, like, okay, I have drawn an inductance here. It can be anything, right? I don't know what is it. I will just draw a box here. This can be capacitive or inductive, I don't care. So again, my VTH will not change, right? Magnitude of VTH I know, phase I don't know, I don't care about the phase. VTH, and this will be resistance RTH, that is 25 by root 2. This box is there again, plus J 25 by root 2. Here I have a series RLC circuit, LC. So ultimately I know this combination will be whatever, like this is either this is plus minus. If this is plus minus, right, then this combination will be minus plus. I don't care this will just negate, right? This will just cancel the reactance part. 25 by, this is under root 2. Under root 2. Okay, so I don't care what is this, whatever is this. Okay, ultimately it will cancel out. So ultimately my circuit will be purely resistive only. And what is the value of resistance? It is equals to the RTH, that is 25 by root 2. Okay, so what will be the current? Current will be like VTH by the 25 by 2 plus 25 by 2, so it will be 25 root 2, the magnitude whole square into RL. RL is 25 by root 2. So now I will calculate what is the magnitude of VTH. Magnitude of VTH we have already calculated, 462. So it will be 462 divided by 625 into 2. Yeah, I think yeah, that is correct, into 25 by root 2. So this will be 462 divided by 25 divided by root 2 whole square into 25 divided by root 2. So this will be around somewhat 3017.76 watts. This is a very good question, and this is a very tricky question, and this is the highest level that they can ask, right? So I have taught you the highest level basically. So that's pretty much it basically for this lecture, and we have ended our network theorems. In the next lecture we will start with a new chapter, that is two ports network. Okay, so I hope you have enjoyed this lecture. If you did, make sure to hit a like on this video, and I will meet you in the next lecture. Until then, happy learning.